grade 11s, welcome to another series of iCamp lessons. So today we'll be continuing with our trigonometry. So this forms part of practice, as we may have covered the theory content that was meant to bring about understanding of your trigonometry, especially for paper 2, right? So today, as part of practice, we'll be looking at your Northwest Provincial Government paper, which is paper 2, grade 11. It's a November 2025 paper. You may refer to this as well. Right, so we'll be covering trigonometry. As I've said, I've covered other questions in the previous videos. Please don't forget, if you are seeing this from YouTube, just don't forget to like, comment, subscribe, and share the video with others if you find it helpful. So let's look at what we have, right? So here I see what looks like a trigonometric graph, right? I see snakes. They are not really scary, but I see what looks like your trigonometric graphs, and we cover trigonometric graphs at length in terms of laying the foundation. So let's see how we can solve this or what we have here. So we are being told that in the diagram below, the graph of f of x is equals to a cos x and g of x is equals to sine bx are drawn for the interval 0 to 360, right? So it starts from 0 to 360, and you have your g of x, which is this one, and then you have your f of x, which is this one. So in this case, 6.1, we are being told that we need to determine the values of a and b, right? So we need to determine the values of a and b, right? So I'm just going to say 6.1. Already we are being told, right, that we have f of x is equals to a cos x, and then you also have your g of x is equals to your sine bx. Right, great. So what we have here, you need to remember your standard form of this, right, is if you have your y is equals to a, let's just say a cos bx, right? So a is usually your amplitude, right? So the absolute value of a is what you would call your amplitude, right? And then b is what will be defined by the period, and your period of the graph, right, for sine and cos is usually given by 360 divided by b, right? So b is a scaling factor and it can be anything, right? So you have to remember these, right, before we can go into solving this problem, right? So when we look at f of x, we are required to determine the value of a, right? So remember what we said about the amplitude. So amplitude is the distance from the origin of the graph to the maximum value of the graph, right? So in this case, if we want our amplitude, so our amplitude will be from here, right, to here, right? So this will be 3 units, and it also can be from here to here. This can be our amplitude, and then this can be our amplitude, right? So therefore I can simply say my a, the absolute value of a, right, it's gonna be the absolute value of 3, right, and it's 3. Therefore a is going to be equals to what? 3, right? So I have my value of a now, right? I have my value of a. So how do I find the value of b? Remember, b, we said, is your scaling factor, and it defines the period, right? So if you look at f of x, in this case, this is your f of x, your g of x, if you look at g of x, right, the period of g of x is just 360. It starts from 0, it intersects the graph at x-axis at 108, and then it goes back to the origin of the graph at 360. Right, so therefore your b is just going to be 1, right, because it makes the period 360, right? So your b is just going to be 1, right, because the graph or the period of the graph is just what? Is just 360. Great. So now we can go to 6.2. So 6.2, it's saying determine or write down the range of f, right? The range of f. So remember, the range we are looking at the y values, right? The y bounds, right? So in this case, it's going to be y. It's going to be values between -3 or +3, right? So I'm including this equal sign because it is included, or I can simply write this as y is an element from square brackets -3 to 3, right? I'm talking about that of x. So this is how I will determine the range, right? And then from here, I go to the next question, right? So the next question, which is going to be 6.3. Determine the value of p rounded to 2 decimal places. The value of p. So p is a point at on f of x or g of x. So I can choose any, right? I have a point and I know the value of x at a, right? So you have a, which is in coordinate 71.6 paired with p, right? 71.6 paired with p, and it's a point on both graphs, right? So I can use any graph. So I'll just choose the easiest one, which is g of x. So g of x says it's going to be your sine of x, right? Because remember, b is equals to 1. So already I do have x, right? So this will be my x, this will be my y, right? So I'll just substitute p here, and then I am going to be left with sine of 71.6. So my value of p in this case is going to be, if you punch your calculator, you should be able to get 0.95, right? 0.95. So this should be true even if you use g of x. Even if you use g of x, your g, even if you had used your f of x, you should be able to get the same answer, right? So if you say y, or no, if you say p is equals to 3, your cos of 71.6, your p is just gonna be your 0.95. So you should be able to get the same answer regardless, right? So this, I think this was supposed to be 6.3, right? Now let's look at 6.4. So 6.4, it says determine the coordinate of b. So we are talking about now 6.4. So I want you to notice something b, right? So if you look at this graph, right, b is symmetrical about a, right? So it has it forms a symmetry, right? Because also g of x, right, is just a normal sine graph, so it means that it will form some part of symmetry, right? So the best way in which we are going to do that is at b, right, these points are going to be symmetrical about each other, right? So at b, y is going to be the same, but it's going to be in an opposite direction. So here in this case, your y at b is going to be your negative 0.95, right? And therefore, if you have this, you can simply find your x. So if you have 0.95, you are just going to say sine of x, right? And therefore your x is going to be your sine inverse of 0.95. And if you do your calculation properly here, you should be able to get 251.60 degrees, right? And it makes sense because it is too far, or it is too closer to 270 degrees. So it makes sense this way, right? So now let's look at 6.5. So 6.5, it says calculate the length of CD, right? Correct to 2 decimal places given CD is parallel to the y-axis, right? And the y-coordinate of C is 2p. So we are already told that here, the y-coordinate, so you just have your x-coordinate, but the y-coordinate here is 2p. So we are already told that. And also remember, what do we know? We know the equation of f of x. So C is at f of x, right? So C is at f of x. C is at f of x, right? And what is f of x? Your f of x is 3, should be 3 cos, right? It's going to be your 3 cos of x, right? Already we know that you have C, which is x and 2p, right? So we can just substitute, right? We'll just substitute and put 2p is equals to 3 cos of x. Remember, what do we know? We know that p is equals to, and we are going to take the positive one. So p, right? P at C, so P at C should be greater than or 0, or it should be positive, right? So that means that we are going to take the positive one, right? So it's going to be 2 is equal to 0.95 equals to 3 cos of x, right? And then this is going to give us 1.9 is equals to 3 cos of x. And then if you say divide by 3, you're going to have x is equals to your cos inverse 1.9 over 3. Right, and then if you punch your calculator, you should be able to get 50.70, right? But remember, this is not the final answer. If you look at x, it's too far from what? From the x-axis. So you are just going to say x is equals to 360 degrees minus 50.570. And then the answer that you are going to get is equals to 309.3 degrees, right? So now we have what? We have x. So now if we have x, then we need to find what? We need to find d. Now we are working with d, right? So we are working with d. So d, what is d? So d is at g of x, right? So d is at g of x, right? And we know that g of x is equals to your sine of x. Right, so we already know that this will share the same value of x, right? So D and C will share the same value of x. So D and C will definitely have the same value of x, right? Because they are along the same x-axis, right? The reason it's because they are along the same x-axis, right? So that means that your y is going to be your g of x is just going to be equals to your sine of 309,3, right? And then if you punch your calculator, you are going to get a negative 0,77, right? And therefore, remember, what do we want? We want the length of CD. We want the length of CD. So we are going to take 2p, right? We are going to take 2p and subtract this one, right? So therefore, CD is going to be 2 times 0,95 minus 0, it's going to be minus 0,77, right? And therefore, if you punch your calculator, this is going to give you your 2,67 units, right? Simple, right? Great. So yeah, that's how you go about solving this. It was a very interesting question, so please do make sure that you follow it up and you try to ensure that you understand whatever is being displayed here. So let's look at another question. Right, so if we look at this last for the purposes of this video, so here we have your area sine rule type of question. So they are saying in the diagram below, ABC is drawn with D on AC, right? As you can see, with D on AC, right? Such that your AD, right? So your AD is going to be equals to your DC. So this and that is going to be equal. So this is going to be equals to this. So your AD is equals to your DC. So line BD is drawn, right? So you have your line BD drawn. So BC is equal to 160 millimeter. AB is equals to 60 millimeter. And we are being told that angle ABC, right? Angle ABC. So this should be the angle ABC, right, is equals to 60 degrees. So this entire angle is going to be equals to 60 degrees. Great. So here, in order for us to solve 7.1, we have to calculate the length of AC. Have to calculate the length of AC. So here, this is your typical cosine rule question. So you have two sides, right? So you have two sides. This is the side that you have, and this is the side that you have, and then included angle, right? So in order to find AC, you are just going to use cosine rule, right? And the reason why you are going to use cosine rule, right? And the reason why you do that, it's because you have two sides, right? And an angle between the two sides. Right? So the cosine rule, it's just going to say your AC squared is going to be equals to your AB squared plus your BC squared minus 2AB times BC cos of angle ABC, right? It's going to be cos of angle ABC. So this is going to be your AC squared is equals to, what is AB? AB is going to be your 60 squared plus 160 squared minus 2 into 16, 116, right? Times your cos of angle 60, right? So now you are just gonna have to punch your calculator. You are allowed to punch your calculator. You can punch your calculator on the entire of this thing, right? So you are going to get your 19600, right? And then when you square both sides, you are going to have your AC as your 140 millimeter, so you don't have to forget the units. Now let's look at 7.2, right? So 7.2 hence prove that the area of triangle ABD, right? The area of triangle ABD, right? The area of triangle ABD is equals to that. So is equals to 1200 root 3 millimeter squared, right? So that's what we are required to prove, right? Remember something about a sine rule, right? We may have spoken about this. For a sine rule to work, you also need two sides, right? So you need x, and then included angle, right? So we are just going to apply the same principle as well here. So we are focusing on triangle ABD, right? ABD. So what we are going to need in this case, so I'm just going to write, let me just draw ABD here. In fact, let's just do this. Yeah, it looks like it. So you have B, you have A, and then you have D. So this is the angle that we want, right? This is the angle that we are going to be wanting. We already know that this is 60 millimeter. And if AC is equals to 140, that means that this is going to be your 70 millimeter. Because remember what we said, AD is equals to what? DC. Right. So we agree on that, right? So we can agree on that. So what we can do, right? So we need to find A, right? So we need to find your angle A, right? So in order for us to find angle A, we are going to focus on the entire triangle, the big triangle. So we are going to say in triangle ABC, right? In triangle ABC. So we are going to use your sine rule, right? So we are going to use your sine rule. So you are going to say your sine of angle A, right, divided by your BC, right, the corresponding side. And then from there, you are going to say your sine of angle A, B, C is going to be your AC, right? So you still have to say sine of angle A, and then what is BC? So BC is already 160, and then your sine of ABC is what? It's going to be your sine 60 all over what is AC. AC should be 140, right? And then from here you can simply say sine of A is equals to 160, because we are going to multiply by 160 both sides. 160 both sides, so this and that will cancel. So we are going to have 160 times your sine of 60 degrees all over 140. So if you punch your calculator, right, if you punch your calculator, I can already tell you for free that this you can find using your special triangle. So this will be your sine of A, right, is equals to you can just write it like this, and you can from here find your answer, which is gonna be 4 root 3 all over 7, right? So you have your sine A. If you want, you can simply just punch it and you get your answer, right? You can simply just punch it and you get your answer, or you can just leave it here, and you will see why that will be important, right? Because if you want to find the area of this triangle, I'll write it now on the other side. Should be like this, and then I copy. So the area of this triangle, the area of triangle ABD is just going to be your half AB times AD times your sine of angle A, right? So we already know what sine A is from here, and we know what AB and AD is. So we are just going to say 1 over 2 times what is AB, it's 60 centimeter. This is going to be 70 centimeter times your 4 root 3 all over 7. And then this eventually is just going to give you the answer that they said we must prove. So this concludes the end of our geometry. So we'll meet on another video where we'll be doing more and more of these questions, so that we try and understand everything, so that by the time we write exams, we are perfect in this aspect. Thank you for tuning in until thus far. I hope you enjoyed the lesson. If the lesson helped you, please make sure to like, comment, subscribe, and share the video.